Okay, so now that we know what concavity is, the shape of a cup or the shape of a frown, we have to find out how do I do this analytically using calculus and algebra. So let's just define a couple of things here. A possible point of inflection is where these concave up and concave down changes occur. So just like we had critical points in the first derivative, we have things called points of inflection or possible points of inflection, which I like to abbreviate as PPI. Our possible points of inflection are anytime our second derivative is equal to 0 or it's undefined. So it's the same process, except instead of using the first derivative, I'm going to use the second derivative. Concave up and concave down are the same way that we did it for increase and decreasing, except anytime my second derivative is positive, that's concave up. Anytime my second derivative is negative, that's concave down. And a point of inflection is actually whenever it changes from concave down to concave up. Concave down to concave up, or if I change from concave up to concave down. If something is concave up to concave up, there is no change here, so it is not a possible point of inflection. So let's do a practice problem to see how this works. And this says, state the interval for which the graph of the function is concave up and concave down, and the coordinates of any points of inflection. So what we shall do first is find our possible points of inflection. Okay? So a possible point of inflection is when I take the second derivative and set it equal to 0. So in order to do that, I have to take the first derivative, which is 12x minus 4x cubed. And I'm not asking for increasing or decreasing, so I can continue on from here. I take the second derivative, which is 12 minus 12x squared. So here's my second derivative, and to find a possible point of inflection, I need to set this equal to 0. So what I'm going to do first is factor. So I'm going to factor out of 12, get 1 minus x squared is equal to 0. If I do this, I get divide by 12, and what we see is the 12s cancel, and I get 0, so that doesn't matter. 1 minus x squared is equal to 0. 1 minus x, 1 equals x squared, right? And if I continue, I get x is equal to plus or minus 1. Okay? So I'm done with finding these, and so I have two possible points of inflection. One is when x is equal to -1 or when x is equal to 1. Okay. So let's do the same thing we've done for the first derivative test. I'm going to draw a number line. I am then going to do my possible points of inflection in order. So this -1, this is +1. Okay. And so I'm going to do test points. So let's do a -2 over here. Let's do 0 over here and a +2 over here. Well, if this is a second derivative test, where should I plug these test points in? Correct, into my second derivative. So f double prime of x, we know it is 0 here and 0 here because that's what we set it to. But let's now plug into what we have. So just as a reminder, f double prime of x was equal to 12 times 1 minus x squared. Alright, so if I plug in -2, -2 squared is +4. 1 minus 4 is -3 times 12 will give me a negative number. So I know that this section is negative. If I plug in 0, it cancels this out and I get 12 times 1, which is a +12. So I get positives all over this section. And if I plug in a +2, I also get 1 minus 4, which is -3 times a +12 gives me a negative number. So in the first derivative test, we usually use the words increase, decrease, but since we are in the second derivative test, we're going to use concave up and concave down. So wherever I'm negative, I'm concave down. Wherever I'm positive, I'm concave up. And wherever I'm negative, I'm concave down. So if I were to sketch this, that gives me a frown, a cup, and a frown. So is there a change in these different areas? So at -1, I change from concave up to concave down to concave up. So my points of inflection, so they're no longer possible points of inflection, but they are points of inflection. Point of inflection is at x is equal to -1. I also have a point of inflection right here because I changed from concave up to concave down, so I can include 1 as one of my points of inflection. If I read the question again, it says, state the intervals where I'm concave up and concave down, and then find the coordinates of these areas. So if we write these down, let's use this. I'm concave up from this section to this section, which is -1 to 1. I'm concave down from -infinity to -1 in union with this section right here, which is 1 to infinity. So there are my intervals. The last part says find the coordinates of the points. Since they're coordinates, I need to find the y values that correspond to this. So in order to do that, what equation should I plug it into? Good. So plug x into the original function f of x to find the y coordinate. So we take a look and see what f of x was. So the equation for f of x is equal to 6x squared minus x to the 4th. So I'm going to plug in f of -1 to find the y value, and I get 6. -1 squared is +1, and negative x to the 4th, well, -1 to the 4th is going to give me a 1, and I keep this negative, which gives me a 1. So 6 minus 1 is equal to 5. So our first point of inflection is at -1, 5. I also have to plug in my second point of inflection. So I do 6, 1 squared is 1, 1 to the 4th is 1, and that also gives me 5. So my next point of inflection is at 1, 5. So what we're going to do is we're going to practice finding concavity. So at the end of the day, once we find that increase, decrease, concave up, concave down, maximum mins, points of inflection, we can then draw the graph of a function. So that's all for today. Please make sure you answer the quiz questions, and I'll see you tomorrow. Thank you.